Alright, I'd like to talk about the Cauchy-Goursat theorem from complex variables. So if f of z is a holomorphic function on a region D in the complex plane, which is bounded by a closed simple contour boundary D, which is oriented counterclockwise in the complex plane, then we have that the contour integral around boundary D of f is always 0. How can we show this? Well, it's a very neat fact. Let's do the following. Let's call z equal to x plus iy, where x and y are real numbers. And thus, we're going to call the differential of z, dz, equal to dx plus I dy. This is our form which we're integrating, multiplied by f. Alright, so then we're going to call f of z equal to, it's another complex number, so we're going to call it u plus iv, where u is a function of x and y, and v is also a function of x and y. So, now let's substitute these expressions into our integral and see what happens. So, if we write integral over boundary D of u plus iv times the differential dx plus I dy, what we notice that by writing it in terms of x and y, we're now actually integrating over a path in R2 instead of C, but it's going to be essentially the same, where this path, if you have boundary D parameterized by, let's say, x of t plus iy of t, this will just become a path in R2 parameterized as x of t, y of t, just without the I. Little technical note there. Alright, let's multiply out, and what do we get? We're going to get integral over boundary D of u dx minus the I squared minus v dy, and then I'm going to collect the imaginary terms in another integral, plus I times the integral over boundary D of v dx plus u dy. Alright, now u and v, because f is assumed to be differentiable, holomorphic, u and v must at least be differentiable as well. So we're going to use Green's theorem on both of these integrals. So what we're going to have is that this is equal to the integral over D, this region, of the partial derivative of negative v, or just the negative partial derivative of v, with respect to x, minus the partial derivative of u with respect to y. And I'm just going to pull this whole negative sign outside of the integral for simplicity. Dx dy, and then plus I times the integral over d of partial derivative of u with respect to x minus the partial derivative of v with respect to y, dx dy. Now what we know is that since f is holomorphic, it's has to satisfy the Cauchy-Riemann equations. So its components have the property that uy is equal to negative vx, so that this integrand is 0, and the other portion of the Cauchy-Riemann equation says that ux has to be equal to vy. So this is also equal to 0. So what we get is 0 plus 0i is just 0. And so we have used Green's theorem, two applications here, to show that the integral of a holomorphic function over a closed simple contour bounding the region on which it's holomorphic must be 0, the Cauchy-Goursat theorem.